DKG agent. That's the name of the existing front end in the DKG agent repository. Agents that use decentralized knowledge graph. Go to chat DKG and you will see four agents. Polkabot, consumer, construction, and aerospace. Notice what's missing? That's $30 trillion gap, supply chain. But here's a real problem. Every agent on that page, even the ones that exist, they all suffer from three failures: hallucination, stateless memory, and passive consumption. So we asked, what if agents didn't consume knowledge? What if they actually built it? And we got three blocks: neurosymbolic, self-built tokenomics, and sub-agents. So we decided to flip the name. Not DKG agent, agent DKG. Not agents using DKG, agents building the DKG. This isn't just a naming trick. We built on three research breakthroughs. MemGPT, the 2020 paper that treats context windows like RAM, paging between active memory and storage, therefore giving infinite memory illusion for agents. ELISA OS and ELISA Graph. And this is interesting because Ordinary Trail built ELISA Graph. So why didn't we just use it? As ELISA Graph only does half the job. It just queries Spark wells. There is no knowledge as enrichment and there is no learning and eventually no trust scoring. The deep agents. This is shift from shallow, stateless agents to deep agents. And here's our contribution. We connect all of these to the DKJ across the agent knowledge trust layers, scaling collective intelligence with trust. And this is exactly how we are scaling trust in the age of AI. Three layers, as said, right? Agent layer, we build a deep agents plugin as a DKG add-on repository. The main orchestrator releases its own instruction from persistent file system, which is self-improving, and then delegates to two sub-agents, and which have access to web search and DKG operations. The first enrichment sub-agent have calls DKG get with the client and does web search, combining web and web3. And second sub-agent reads what enrichment produced. So enrichment is producing, you can see the virtual memory, specifically triples, JSON.md and community nodes. And therefore, Weldon subagent harnesses that virtual memory file system and computes the trust logic. And that trust signal is passes to history.json. Then again, these loops go on and it is literally self-improving. For building knowledge layer, there were four phases of knowledge mining on NeuroWeb: discovery, publishing, enrichment, and learning. The existing DKG node handles the first two with create and get. We completed the phase 3 and phase 4, which is enrichment with our enrichment subagent and the learning. As you can see, Valdez subagent with the trust layer is literally self-improving trust logic, not fixed algorithms. And let's see it in action. So our knowledge mining plugin takes time, so I have actually calculated it. As you can see, my prompt was a TS in supply chain we have given the UAL, and then we prompted it into 5 steps. So you can see it first called DKG get, it gets that UAL and then passes through knowledge miner, and this is our main plugin. So when this passes knowledge miner, you can see how its system works. So first thing, here you can see there are 4 memory paths which are populating: instructions.md, triples, community nodes, and history. And it also does some cool file operations. You can see web search, read file, and a lot more. But what happens then when it gathers all the knowledge from from Web3 while with DKG operation and web with the web search from knowledge miner run, it gives us option to create. It's actually not creating, it's enriching and learning. For example, as I've shown you the architecture, the instructions and the triples are the trust signal logic which gets self-improvised and finally gets the trust score. And you can see which operations and which subagents is delegated. And finally, we can simulate, and here's the simulated option of the payment. So that's the future of self-improving tokenomics, micropayments for high confidence data. So now look at the tagline on the slide. AI agents as domain knowledge miners. We showed you supply chain, but swap that domain variable with this. It becomes a healthcare miner, financial miner, or energy infrastructure miner because the memory root are dynamically arranged in the backend. So the architecture stays the same. That's what makes this different. And our reason is that actually I personally like the concept from Melanie Mitchell's work on complexity science. She studies ant colonies. A single army ant, bravery, one of the simplest organisms imaginable. But put a 500,000 together, they become a superorganism. Collective intelligence emerges, not from any central controller, but from simple rules and phenomena trails. And that's what we are building. Individual AI agents following simple rules enrich, validate, publish, but the knowledge assets they create, those become pheromone trails. They persist on your web. They reinforce past that work. They fade when trust score drops. No central controller, no company owning the graph, just emergent collective intelligence, trust signals that evolve, memory that compounds, intelligence that emerges from the interactions, and that's agent DKG.